Hi everyone, this tutorial introduces a topic of differentiation for CSEC Advanced Maths. Differentiation belongs to a branch of mathematics called calculus. It is a process of calculating how one variable changes with respect to another variable. Given a function y equal f of x, the value of y depends on the value of x. So when the value of x changes, the value of y also changes. This change is known as a derivative, and that's an important term that we will meet throughout our lesson. This derivative can be represented by the ratio of the change of y and x, which is written as dy over dx, and this is also read as dy dx. And another way for representing this, if our function is in terms of f of x, then instead of dy dx, we can also write f prime of x. Basic derivatives. So the first one being the power rule. So if y is a function of x and it is written in this form, y equal ax to the power of n, then to differentiate that, we'll have dy dx equal n ax to the power of n minus 1. So really what we did here is that the value we have as a power in our original function, it comes to the front and is being multiplied, and then we subtract 1 from that power. The power rule can be used to differentiate any function in that form, y equal ax to the power of n, such as where a is a constant and n is a constant, meaning numbers. So such as y equal 2x to the power of 3, that is in this form. Example 1. Find the derivative dy dx given y equal 2x cubed. So in this question, we have 2x to the power of 3, and if we look at our rule as before, our power rule is in this form, ax to the power of n. So from the question we are given, a would be 2 and n would be 3. So using the power rule, dy dx equal n ax to the power of n minus 1. So we have just substituting our values of n and a will give us 3 multiplied by 2x to the power of 3 minus 1. And simplifying, 3 by 2 will give 6, and the power here can be simplified as well. 3 minus 1 gives 2. So 6x squared is our final answer. So again, for any question that looks like this or is in this form, we use the power rule, which is this here in dy dx, and we substitute our values of a and n and simplify to get the answer. Example 2. Find the derivative dy dx when we have y equal 5x squared. So remember the power rule, y is in the form ax to the power of n. So our a would be 5 and our n would be 2. Once we have identified the values of a and n, then we just substitute into our formula for dy dx. So n would be 2, a would be 5, and the n minus 1 would be the 2 minus 1. And simplifying, 2 multiplied by 5 will give 10, and simplifying our power as well, 2 minus 1 will give us 1, and x to the power of 1 is just x. So our final answer would be 10x. Example 3, we want to differentiate y equal x squared. Again, the power rule is in the form y equal ax to the power of n when we use the power rule to differentiate. So our a in this case, since there's no visible value in front of x, it's understood as 1. So a would be 1 and n would be 2. So using our power rule, we would have n, which is 2, a is 1, x, and then n minus 1 would be 2 minus 1. And that gives us 2x. That's our final answer. Example 4, to differentiate y equals 7x. Again, we've identified the values of a and n, which is in a form ax to the power of n. In this case, there's not a visible power written here, so x by itself without a power visible is understood as x to the power of 1. Alright, so using our power rule, substituting the values of n and a, we would have 7 x to the power of 0. And from our laws of indices, we know that anything raised to the power of 0 is 1. So then our final answer is just 7. Example 5, we want to differentiate y equal 3 over x to the power of 5. Now this looks a little bit different from the previous questions that we did because it's not directly in the form ax to the power of n. However, using our laws of indices, we can express it in that form. So we know that 1 over x to the power of n from laws of indices equal x to the power of minus n. So 3 over x to the power of 5 is equal to 3x to the power of negative 5. And now that we have it in this form, we can directly use the power rule. So identifying the values of a and n, so that's 3 and minus 5, and then substituting into dy dx, we will get minus 5 multiplied by 3x to the power of minus 5 minus 1. So minus 5 multiplied by 3 will give us minus 15, and for the power minus 5 minus 1 gives us minus 6. This can be accepted as the answer, or it could be further simplified using the laws of indices to give minus 15 over x to the power of 6. Example 6. Y equals square root of x to the power of 7. So again, this is slightly different from the form that we looked at, which is ax to the power of n. Again, we can use the laws of indices to express it in that form. So the square root can be expressed as to the power of a half, and then we have x to the power of 7. And then when we have two powers next to each other here, then we can multiply them, and 7 multiplied by a half is 7 over 2 as an improper fraction. So now we have x to the power of 7 over 2, and this is in a form ax to the power of n, where a would be 1 and n would be 7 over 2. So substituting the values of a and n into dy dx will give us 7 over 2 by 1, x to the power of 7 over 2 minus 1. That's just using this rule. And simplifying, we will get 7 over 2 x to the power of 5 over 2. And this can be simplified even further, the fraction 5 over 2, to give us 7 over 2 square root of x to the power of 5. And that comes from 5 over 2 can be split up to give 5 multiplied by a half. And then the power of a half is what gives you square roots. And we are left with just the power of 5. So this is our final answer for example 6. So our next rule for basic derivatives is the differential of a constant. So a constant is a term that is not associated directly with a variable. So for example, 5 is a constant. But if I have a variable such as x, then that is not a constant. So a constant, the differential of that gives 0. So if a function is y equal k, where k is a constant, there is no variable in this function that could affect the value of y. That is why there is no change in y. So remember that differentiation is a measure of change, and it shows how the change in one variable affects the other one. But if I have y equal 5, there's no x there to affect the value of y. So since there's no x, there's no change in y. Hence, the differential of a constant is 0. Example, given y equal 7, find dy dx. So if I differentiate dy dx, the answer is just 0. There's no working that we need to show for this because it's just a given rule that the differential of a constant is 0. Okay, our next rule is the derivative of a polynomial. So the derivative of a polynomial can be found by differentiating each term individually using the power rule. So this shows a polynomial y equal 4x squared plus 5x minus 3. So differentiating this, as mentioned earlier in our last slide, we just differentiate each term separately using the power rule. And just as the power rule shown here, y equal ax to the power of n, if we differentiate that, we would have n ax to the power of n minus 1. So this is the rule that we are using, and I'm differentiating each term separately. So differentiating the 4x squared, we bring the power to the front and we subtract 1 from the power. So if I bring the power to the front, I'll have 2 multiplied by 4, which is 8. And if I subtract 1 from the power, 2 minus 1 is 1, and x to the power of 1 is just x. If I differentiate 5x, then this is 5x to the power of 1. So if I bring the 1 to the front and multiply 1 by 5 is just 5. Subtracting 1 from the power, I'll have 1 minus 1, which is 0, and x to the power of 0 is 1. So our answer is just 5. And differentiating minus 3, the differential of a constant is 0. So if I differentiate minus 3, that's just 0. We don't need to write in the plus or minus 0 here. We can leave our answer as just 8x plus 5. So this part of it, if you are a bit confused as to how I got dy dx, then go over the previous examples for the power rule. This incorporates how we differentiated a term in the form of 4x squared, or a term with a number in the x alone, such as 5x, as well as how we differentiated a constant. So it's a combination of examples that we did under the power rule. So I'm differentiating each term. I did not write the rule for each term because it's not necessary to show that working in a question when you are doing further differentiation. You can just go straight from y to dy dx without showing that working for how you are applying the actual rule. Alright, the rule here is just to help you in terms of how to differentiate or what's the process of differentiating, but no specific working needs to be shown for this part of it. So I can just do this part of it in my head, or you can do it on the side and then substitute it here. So again, just to go through it one more time. To differentiate 4x squared using the power rule, we bring the power to the front. So this is a, 4 is a, and n is 2, right? So I'm bringing the power to the front and multiplying. So 2 multiplied by 4 gives 8. And for the power here, I'm subtracting 1. 2 minus 1 is just 1. So I have 8x to the power of 1, which is just 8x. And so on for each term. Let's look at another example. So I have another polynomial. Y equal 2x cubed plus x squared minus 9x plus 1. And I want to differentiate y. So dy dx, I'm just using the different colors to show which terms were differentiated to give the result in the dy dx line. So this is a power rule again. To differentiate, I'm bringing the power to the front, so the n comes to the front and it's multiplied by the a, and then we subtract 1 from the power. We are doing that for each term individually. So looking at the 2x cubed, the 3 comes to the front and is multiplied by the 2, so we get 3 multiplied by 2, which is 6, and then we subtract 1 from the power. 3 minus 1 is 2. For the x squared term, the 2 comes to the front and it's multiplied by a. In this case, a is 1. So 2 multiplied by 1 is just 2. And I'm subtracting 1 from the power. 2 minus 1 is just 1. So the answer is 2x to the power of 1 for this part, which is the same as just 2x. Then I have minus 9x. When I differentiate the term with just x, it's equal to the coefficient of x. That's just a number in front of x, which is minus 9. But using the power rule, we have minus 9x to the power of 1. So if I bring the 1 to the front, I have 1 multiplied by minus 9, which gives minus 9. And x to the power of 1 minus 1, which is 0. So x to the power of 0, which is just 1. And 9 multiplied by 1 is just 9. And differentiating the plus 1. Now this plus 1 is not associated with any variable such as x, and we learned that the differential of a constant is 0. So if I differentiate the 1, the answer is just 0. No need to write in a 0 at the end. The final answer would be 6x squared plus 2x minus 9. Alright, next rule, we have trig functions to find the differential of sine x and cos x. So if I have y equals sine x and I differentiate that, these are rules that you need to know, then dy dx would be cos x. And if it's the opposite, if I have cos x, then dy dx is equal to sine x. Alright, so you can just remember that if we differentiate sine, we'll get cos, but if we do the opposite, if we differentiate cos, we'll get negative sine. Example, given y equal 2 sine x plus 8 cos x. Find dy dx. Each term can be differentiated individually, similar to the process of differentiating a polynomial. So this gives us, if I differentiate 2 sine x, the 2 is a constant that remains as it is for this part of it because it's not a constant by itself in terms of 2 plus sine. The 2 is being multiplied by sine. So in our result, the 2 is being multiplied by whatever the differential of sine x is. So the differential of sine x is cos x, and the differential of cos x is minus sine x. So this gives us 2 cos x, and 8 by minus sine x will give minus 8 sine x, and this is our final answer. Then our next rule would be differentiating a function of this form as shown in the title bar, ax plus b to the power of n. So when I have any function in this form, ax plus b to the power of n, notice there are no powers on x, then the differential would be a multiplied by n, and in brackets we have the same function ax plus b, and then we subtract 1 from the power. Example, differentiates with respect to x. The term with respect to x means that x is the variable. So 4x minus 3 to the power of 5 is in that form ax plus b to the power of n. So a is 4, b is minus 3, and n is 5. So b is not really involved in any of the calculations, so we just need to identify the values of a and n and then substitute into our formula for dy dx. So a is 4, n would be 5, ax plus b is the same function inside the brackets, 4x minus 3, same in the brackets, and n minus 1 would be 5 minus 1. Simplifying, 4 multiplied by 5 gives 20, brackets again remains the same, and simplifying the power, 5 minus 1 is 4. So this is our final answer. Example 2, differentiate with respect to x. We have y equal 10 minus 3x to the power of 6. Now remember, our rule that we are using would be when we are differentiating something in the form ax plus b to the power of n. Notice that the a is in front of the x, so a is a coefficient of x. So in this case, it's written with the x term second. So the a value is what is in front of x, so the coefficient of x, and that's minus 3. So minus 3 would be a, b is the 10, and 6 is n. So using our rule for differentiating and substituting the values of a and n would give us minus 3 multiplied by 6. In brackets, we have the function left as it is, 10 minus 3x, and then we are subtracting 1 from the power. Simplifying, that would give us minus 18. Again, brackets remain the same, and for the powers, 6 minus 1 gives 5, and this is our final answer. Example 3, differentiate with respect to x, square root of 2x minus 5. So again, this is similar to an example we did in the power rule, where it is not exactly in the form that we are working with. However, we can use the laws of indices to get it in the form before we differentiate. So this can be expressed as y equal 9 minus 5 to the power of a half. There was a little error in the question itself. I had a 2 here previously. It is supposed to be square root of 9x minus 5. So the square root of 9x minus 5 using the laws of indices can be expressed as y equal 9x minus 5 to the power of a half. And now this is in the form ax plus b to the power of n, and we can use our rule to differentiate. So identifying the values of a and n, we have a is equal to 9 and n would be a half. So dy dx, substituting our values, a would be 9, n is a half, again a in our brackets, ax plus b is whatever we have written in brackets here, which is 9x minus 5, and then we are subtracting 1 from the power, so I have a half minus 1. And simplifying further, we would have 9 multiplied by a half will give us 9 over 2. I'm just leaving it in terms of an improper fraction. Please refrain from using decimals. In brackets would be the same, and in our powers, a half minus 1 gives negative a half. And this answer, the minus a half, can be simplified using the laws of indices to give us 1 over the square root of 9x minus 5. So the half as it is, in terms of the laws of indices, represents a square root, and the negative sign makes it is a reciprocal of what we have, meaning it's 1 over that. And just to simplify a little bit further, this can give us 9 over 2 square root of 9x minus 5. Now, if your answer is left in terms of this form for a paper 2 question, it will be accepted. But in some cases, especially for multiple choice and so on, you need to know how to simplify it as in different ways or as much as needed, because after differentiating, where if you get up to this line, probably maybe the multiple choice question, if it doesn't have this answer, you need to know how to simplify it further to get it into this form, which may be one of the choices. So that's why we need to understand how to simplify further, and it's especially important to review the laws of indices and know how to apply them. So this brings us to the end of this video on basic derivatives, or how our main rules in differentiation. There were quite a few rules which you have learned. So we learned that dy dx represents the change in y with respect to x, and that's called the differential. The differential, or when we differentiate a constant, our result would be 0. When we differentiate a polynomial, we can differentiate each term individually using the power rule. And just to review differentiating certain things, you can just use this table to help you remember or for reference when revising. If I have y equal ax to the power of n, this is the power rule. When we differentiate, we would get n ax to the power of n minus 1. The differential of sine x is cos x. The differential of cos x is minus sine x. And when I differentiate something in this form, ax plus b to the power of n, then our dy dx would be a multiplied by n in brackets ax plus b to the power of n minus 1. Alright, so that is n to the power of to the power of n minus 1. So just use this table. It comes in very handy when revising or when attempting questions for differentiation. It basically summarizes all the rules that we have learned. The only rules that is not here is what we discussed in the previous slide, where the differential of a constant is 0, and when we are differentiating a polynomial, we just differentiate each term individually using the power rule. So other than these two rules here, this table basically is all that we need to know for differentiation and for doing basic derivatives. So next we have an assignment. So this assignment consists of questions involving all the rules that were covered during this tutorial. So please look at the video again. If there's any parts of it that you don't understand or anything that's a bit confusing, it sometimes helps to review it more than once. Alright, so if there's anything you are unclear about, you can just look back at that part of the video in terms of doing the questions, and if you have any further issues, feel free to message me. So our assignment consists of 20 questions. Feel free to attempt them, and that's the end of the video. Differentiation is a fairly large topic, so there are many different parts that we would have to cover as for the CSEC Advanced syllabus. So our next topic in differentiation introduces a rule called the chain rule, which helps us differentiate certain functions. So thank you for watching the video, and look out for the next video on the chain rule.